Ah, good morning. I thought that I would clear up the difference between amylose, amylopectin, cellulose, and glycogen because I think the textbook doesn't really give it a good go considering there were 7 marks for it on our practice exam. So here we have amylose, which is one component of starch, the other being amylopectin, and it's made from alpha glucose monomers, which combine. So what we need to know on the exam are its bonds, its overall 3D structures, and its monomers. So its bonds are these. So we have an alpha glucose linkage, which is basically we have a look at the oxygen is considered 0, and so we have the first carbon here. And so the first carbon has the H pointing up, so therefore it's like it's an alpha glucose monomer. And then the alpha glucose linkage is between that first carbon, which I like to call like the alpha carbon or whatever, and it combines with the fourth carbon on the next monomer over, creating a glucose or glycosidic linkage, and specifically an alpha glucose linkage, because this H is pointing up as in alpha glucose. Also of consideration is the fact that there is technically another linkage here, which is from the 4 to the 1, which is a glycosidic linkage. If on an exam, say, you were to compare amylose to cellulose, they would want you to pick up on the fact that in both there is technically a 1,4 glycose linkage in both, because in both the first carbon and the fourth carbon are connected through an O, and so that's a glycose linkage. But specifically in amylose, it's a alpha glucose linkage. So you can consider this carbon to be the fourth carbon to be the glycose carbon in the linkage, and then this first one to be the alpha carbon. At least that's how I like to remember it. It's not technically correct, but it helps me. And so those are your 2 bonds, the alpha glucose, and within and larger on top of that is the glycose linkage. And then you have alpha glucose monomers, which make up amylose, and this results in its overall 3D structure being unbranched with many straight chain repeats. As can be seen, there's 300 to 600 straight chain repeats, and it also forms 3D helical structures. Now this was, I think, only a one-liner in the textbook, but if we need to compare amylose to cellulose in the exam, it will be a mark, so it's important to remember that. And I think these are the 5 things: the alpha glucose linkage, the glycose linkage, unbranched with many straight chain repeats, forming 3D helical structures, and that the monomers are alpha glucose. Okay, so that's amylose. Now we'll move on to amylose's kind of brother, amylopectin, which is kind of like a more branched version of amylose. It's the second component of starch. It forms with amylose to create starch. Okay, so here we have basically down here is the exact same as amylose. Same bonds, everything. So as with amylose, we have a 1,4 alpha glucose linkage and a 1,4 glycosidic or glycose linkage in the straight chain versions. And its monomers are also alpha glucose. However, we have a difference here, which is the formation of 1,6 alpha glucose linkages. Now this happens when this guy interacts with the OH that's that interacts with the OH that's normally present there, and these guys interact, and that causes this bond over here, and that causes branching in the molecule. So we have a regular amylose bonds in the straight chain, but we also have 1,6 alpha glucose linkages. And now this creates a branch every 20 to 24 repeats. Thus, the resulting structure is branched, as we said. It's also non-rigid, and important for the exam, it forms compact spirals or granules. Again, this is only a one-liner in the textbook, so if you want that mark, you need to probably memorize this, these two, same as amylose, need to remember that, and need to remember that. Now, there's also another kind of molecule that comes up in the textbook, and it's glycogen. Now, glycogen is basically exactly the same as amylopectin, except it does not form starch, and also instead of 20 to 24 repeats of straight chain monomers, it only has 7 to 11 repeats. And so if you were to say distinguish between glycogen and amylose, that would be your distinguishing feature. Glycogen is even more branched with 7 to 11 as opposed to 20 to 24. Now we've covered amylose, amylopectin, and glycogen, and they're all made of alpha glucose monomers. Now we'll move on to cellulose, which I think is one of the most abundant organic molecules out there. Yeah, and you see it everywhere. It's in wood. It's I think the primary constituent of wood. But yes, so here is cellulose. I'll just write cellulose up there. Or here. Cellulose. Beautiful. Now cellulose is I like to think of it as a beta-glucose version of amylose, except there are some distinctions. So the monomers are beta-glucose. There is, as with amylose, amylopectin, and glycogen, the 1,4 glycose linkage. However, each of the monomers, because the monomers have their H's pointing down, as can be seen here, they form beta-glucose linkages instead of alpha-glucose linkages. And also of note is the fact that, look over here, it appears that the H's are pointing up, but actually they are in relation to this O pointing down, which still makes them a beta linkage. And this, the alternation is because of the way it forms. And it's I think it's beyond the scope of this course. All you need to know is that the monomers kind of flip in their orientation, and that creates a beta linkage in each one, even though the H's appear to be pointing up. And there's also a 1,4 glycose linkage, which is similar to amylose, amylopectin, and glycogen. And as a result of those bonding and that alternation, we have an unbranched and linear polymer that forms microfibrils. This also makes it rigid and strong, and it has an extremely long chain. It's longer than amylose, I believe. And so yeah, that's, I think, all we need to know in relation to amylose, amylopectin, and cellulose. For cellulose, the marks on the exam are, I believe it's unbranched and linear, microfibrils, rigid, the 1,4 glycose, the beta-glucose linkage, and the monomers. Sorry, the monomers. So yeah, have a nice day, and I think if you memorize these things, it might be an easy 7 marks on the exam.